So with precision-based rounding, we're really going to be rounding to place value, but by adding in this idea of precision, we're also kind of mixing in the idea of our significant figures. So really this is going to come up in some special cases. It's going to come up when we're rounding up with a whole number using a 9, and if that 9 creates a 0, then what we're going to do is create an overbar. So that scenario is going to come up in this second example right here. This other case, when we round up a decimal, and sorry, that's the main difference here. This is with a whole number, and this is with a decimal with a 9, and we're rounding up to create a 0, then we're going to include an extra 0 in the decimal place. So I'll return to those. It can be really difficult to understand just reading it, but hopefully seeing it happen will help out. So really we're being careful of these cases where we're rounding up or down with, just rounding up with 9s and creating 0s and what to do with those 0s that are coming out. So this 3,897, and we're being told to round to the thousands place. So there's our rounding digit. So we need to look at our test digit, which will tell us whether we round up or down. Since 8 is large, that's telling us to round up. So that 3 is going to round up to a 4. And then we don't need to worry too much here about these precision-based rules that we're talking about, because nowhere here is a 9 rounding up to a 0. So this is just 4,000, and then that's done. Now in this next example, if we go through that same process, so I'm rounding up the hundredths place, which is right there. So if I look at my test digit, that's telling me to round up. So when we round up with these 9s and how they kind of layer together, is like we have 9 is rounding up to a 10 right here. So that's where we're going to end up with a 0. But because that's 10, that's going to affect the 4 right here. Instead of having 4,000, we're bumping up to 5,000 and following through. Now we're not quite done here. If I was just rounding to the hundreds place without any idea of precision, this would be done. But with the idea of precision coming through, this is the case of working with a whole number. So we have a whole number right there, and that 9 turned into a 0 by rounding up. We want to include an overbar on that 0 that we rounded to. So it's the 0 that's equivalent with the, or lining up with the rounding digit. I would put a 0 right there. And what this shows is a level of precision that we have with this number, because we were focusing on rounding this piece right here, and that really did round up to 10. It's really close to 10 with that 998. Or rather, thinking of that 998 is super close to 1,000. So with that, with this rounding up and getting the 5 out, without the overbar, it's stating we have precision to the thousands place. But in this rounding, we were so close there, and because of the nature of how this is rounding, with such large numbers rounding up to 1,000, we get a little extra accuracy right there. So with whole numbers, if you have this rounding up with specifically a 9 turning into a 0, what you'll do is include an overbar. All right, rounding to the tens place here. So what I'm going to do is look at my rounding digit, which is right there. Now this is a case where I don't have 9s, I'm not rounding any 10s, so this is just straightforward. The 3 tells me to round down, so that 4 is just going to stay the same. So this is 2,840. So nothing special there, just kind of straightforward rounding to a place value. All right, let's look at decimal. So tenths place, so we're right here, which means my test digit is this 6, which is large, so I'm rounding up. I'm not doing anything with 9s here and rounding up 9s, so this is going to be pretty straightforward of rounding to the tenths place. We're going to have 0.4 rounds up to a 5. and then we would leave it just like that. Now, something I will note is I do not want to put a 0 right there. That would be implying more precision than we have with this rounding right here. So I would take that out and just leave it as a 5, because it's the difference of this is one significant figure, this is two significant figures, but we don't have that precision. All right, this case right here is going to be special in terms of what we're describing up above. And notice that this one's pretty similar to that last one, but the difference is going to be we're rounding to the hundredths place. So we're rounding right there. And this is going to be a case of a 9 rounding up. So we're going to round up, which again basically creates a 10. So what we're going to have is 0 point. That 4 rounds up to a 5. And then where we had 9 before, we have a 0. And in this case, we want to include that 0. We want to show that we do have precision to that hundredths place. So we're going to keep that 0 right there to show that we have two significant figures, whereas this last one, where we didn't have that rounding up of 9s, it was just rounding that 4 up to a 5 directly, we only have the precision to the tenths place. But with this one, we get precision to hundredths because really we were focused on rounding over here, and that 9 rounded up to a 10. All right, this last one here, round to the thousandths place. So that's going to be at this 8 here, and nothing different in terms of there's no 9s to work with. So really we're just going to look at that 4, which tells us to round down. So we're going to keep that 8 as it is, and that'll be a 0.568, and we would leave it just like that without any extra zeros on the end.